Welcome back to Coding Game Winter Challenge 2024. We're doing it in Python. We've got like a couple of days left. I mean, realistically, this is probably the last stream. I don't like to stream on the final day. Like the final day, I don't like to touch things because there's a chance of stressing out and screwing up, or worst of all, coming up with a brilliant idea but not enough time to execute it. That's the most stressful thing. But yeah, so this I guess this might be my final stream. So let's have a look at what's going on. So we are rank 433 in gold. It's pretty good so far. Try and have a look at what is causing us to lose. Okay, there's a lot of losses there. Let's have a look at them. So, why? Oh, I'm blue. Oh, okay, okay. Alright, it was a close game. I don't think there's really any fault here. It was just a close game. Alright. I want to find some games where there's a very obvious flaw. Hello, Dark Slayer. Doing good, thanks. Probably my final stream of this coding game thing. Alright, what the heck happens here? Oh, he destroys my route. Interesting. Not much I can do about that. Well, I suppose I need to defend my route, but... Out of curiosity, are you becoming a video game developer? Not really, but I don't know, this year I might give it more of an effort. Maybe try some more. Maybe game jams, or try and get into it more. Yeah, last year I had a go at the Captain Coder's game jam in Godot, and that was pretty good. I enjoyed that. So yeah, I might do some more game dev related things this year. Oh, that's something I try. Right, well, we can't do much about this. I looked in your channel while you were working on developing something while I was playing Bloodborne, but also listening to you at the same time. You mean recently? Like the other day? The last few days I've been doing this coding game. About a week ago. Oh. It may have been Advent of Code. Oh no, it probably was still this. Yeah. Okay, so... Okay. I think we've got to start doing a lot of mathematics. Maybe. I haven't really done much mathematics for this. I did a lot of mathematics for Heaven of Code. This one's mostly just like breadth first search algorithms. Okay, so I'm not sure what to do now because okay, we've got like one day left. I don't want to start anything that will take several days to develop. I want to look for things I can improve. Well, let's have a look at my to-dos because okay, this one's scoring. That's that's a pretty good one. We can seek out. We want to go for. Oh yes, how did the vampire game go? Yeah, I finished the vampire game. Yeah, it was alright. That was during the spooky month. Yeah, it was a nice game. Not amazing, not a brilliant game, but it's nice. It had a nice story at least. A nice depiction of London. Well, London if it were ruled by vampires. Were you looking for a vampire game like Castlevania? You know, like the PS3 version. Castlevania, I've watched people play it. It's not really my kind of genre, like 2D platformer or hack and slash type games. But I like some of the lore behind it and some of the like the weapons and inventory and stuff. It seems pretty cool, but I never really played Castlevania myself. There's supposed to be a TV series, isn't there? Apparently it's quite good. I've never seen it. It's by is it by Amazon? Alright, so I think we want to rank okay, so that's one thing we can do. We can always target the organs which have the largest subtrees. State-based BFS using protein, income, and storage. Oh man, this is a task that'll take more than a day to do. I don't really want to do it. Honestly, part of me wants to just pack up and finish here because I'm kind of happy with this rank. We'll see if we can add some things. It might not be a long stream. Sorry if I'm causing you stress. No, not at all. I'm always happy to talk about video games. I don't know anything about Bloodborne. The only thing I've seen about Bloodborne is the demake. The demake of Bloodborne, but I haven't even seen the actual Bloodborne. It's like a demake for the PS1 engine. Is Bloodborne a bit like Dark Souls? Interesting. One of these days I'm gonna have to play Dark Souls. I mean, it's not my kind of game. I don't like things which have precise timing or rely on you dying a lot to learn how to get past bosses and stuff. But it's a piece of video game history at the same time. And I feel like I just have to play it to actually call myself a gamer. One of these days. Well, there's a remaster, isn't there? Is it good? Dark Souls Remastered. Well, it's quite expensive, but...
Peggy 16.
Looks good. Hello, Zagundes. You doing CodinGame? Started the stream and I just have no idea what I want to do right now. It's like I've reached a point where my bot is quite good. And I'm quite happy with it. And we've got like 1 day and a bit left, and I don't really want to add anything. But I did start the stream, so now I have to do something. Are you good at data analysis? I'm good at some aspects of data analysis, yeah. I did a bit of data analysis for Amazon a few years back. Mostly to do with Prime Video, databases, running some like notebooks. Are you more into like Spyro the Dragon, Bandicoot, Mario, Donkey Kong, Legend of Zelda, those kinds of games? No, not really, but I do really like Spyro the Dragon, and I did enjoy Crash Bandicoot. I haven't played much Mario, and I've played Ocarina of Time for Legend of Zelda, but nothing else. Of all those games, I prefer Spyro the Dragon. I like the theme and the atmosphere of that game, but I'm not really that into platformers in general, although 3D platformers I kind of prefer to 2D platformers. Wish the Spyro could fly more. Yeah. It would be a whole different game if it was a game where you actually flew around, I suppose, but it would be interesting because not many, at least for those consoles, not many games really gave you, you know, like proper flying abilities. I guess it requires like much better level design, because then you have to think about ways to kind of, you know, halt people's progress or make some kind of progression system, because if you could just fly everywhere, then yeah, you could go anywhere. Could I help you with some ideas? I mean, yeah, I could give very vague ideas, but I mean, it would depend on what you have in mind. So there's like, are you talking about like a personal project, or like is this like a something related to something like CodinGame? Yeah, I can't think of many games where you actually fly. Alright, so I think today I will try this enemy organs thing. But the thing is, usually there's only one enemy to attack, so... Oh, you know what we should try? No, not this. We should try sporing, because that's an important... That's an important mechanic, and I've not actually used it. Basically what I'm saying is games that are simpler, that don't have to be so complicated, but they are fun, and when they are complicated like this, it kind of takes the fun sometimes out of it. Because these days games are nothing but competition, it seems like, on the newer ones. I think we've had a mix of games that are over simplistic in the gameplay, as well as games that are overcomplicated. Like some examples, like Witcher 3, for example, is a fantastic game and has a really great story, but the gameplay is actually kind of bad and kind of simple, and I hate the way the potions work. So this is that for me is an example of a game that like was still pretty fun to play, but more for the story than anything else. The gameplay's not great. In fact, I would say the actual combat mechanics and stuff was better in the previous Witcher games. I have a dataset with COVID variants, their growth, amount of patients with the variant, and the genetic distance from latest ancestor. I need to make a model visualizing this. I've made a phylogenetic tree, which looks nice, but the amount of patients is seen by the size of the nodes on the tree, which makes it possible to see exactly how many have that disease. How can I make the amount of patients easier to see? So this is more of a visualization question, right? So you have all the data you're trying to... I see. Are you using a program to visualize it? Like, have you tried something like GraphViz? Because I think GraphViz has quite a lot of options, which some of which are used by bioinformaticians or bioscientists for this kind of thing. Julia. I don't have any ideas. I haven't really played much with visualization tools. I mean, my only experience is with GraphViz, and I remember you can do some cool things with GraphViz, such as making kind of almost like animations where the graph grows and things kind of spread out, and that was quite useful for like genetic stuff or bioscience stuff. But other than that, I don't really have any ideas. Like, I haven't played with many of those tools. What are you working on? So we're playing a game which involves having organisms. It's a bit like Conway's Game of Life, where you have an organism and it expands into new cells. So let me run it here. We are red. The enemy is blue. So we can expand our organism, capture proteins A, B, C, and D in order to grow more and more. And at the same time, we're sort of trying to attack the other guy. So it's almost like an RTS strategy game. While turn-based strategy game would be more accurate. Okay, but we get destroyed here. So you gather resources from proteins, and then you try to expand. But I mean, we're facing the boss. The boss is too powerful. I don't think I can beat the boss, but we can beat peers. Like Mr. Kreska, for example. Are you a mathematician? Yes. I don't do as much maths nowadays, but I did study and research in the fields of theoretical mathematics and pure mathematics and theoretical computer science. Yeah, so we have no hope of beating the boss. We could try playing against Kreska, though. Let's try this. Okay, so this was a bit of a stalemate, but we lose. Why did we lose? We shouldn't lose. Why did we not capture all these remaining cells? Cannot grow in front of tentacle at 9-2. Why are we trying to grow there? I thought I fixed this. Well, we've got a bug. And that's a bad bug, because it caused us to lose a game, so... We're trying to grow... Oh. I see the problem. I'm applying for university next year, but can't choose between engineering or medicine. Do you have any tips? Oh... Very difficult for me to give any input on that. I mean, they're both fields that will still be in demand 10, 20, 30 years from now. I mean, usually the best decision is what you enjoy more, because people who don't enjoy the thing they go into have a higher likelihood of like dropping out or switching subjects or something, but I can't give you any tips on the decision. It's impossible for me to know. All I know is engineering needs good mathematics skills and medicine needs good chemistry skills. And if you've got both of them, then that just makes the decision even harder, I guess. I love maths, but I don't think I could make a career seeing how some of my peers are already doing university courses. Well, I mean, you're not necessarily in competition with your immediate peers, are you? Like, you could all end up at university or in jobs and stuff. It's so, like, I wouldn't let that discourage you. I mean, there is a lot of competition for both of those fields, definitely, but still, the world is in need of engineers. All the more now that so many jobs are being replaced with AI and stuff like that. That just means we need more engineers, and the world is always going to need more doctors. So, I wouldn't be worried about, you know, lack of the competitiveness or the lack of ability to actually get a job. Feels like the concentration of smart people in engineering is a lot higher than in medicine. I would say it probably is, because medicine is one where you just have to put in more. You have to put in more years of hard work to. You don't necessarily need a higher academic, mathematical ability, for example, for medicine. So it's a lot more work-based, memory-based, like learning a lot of techniques and building up your knowledge. Whereas engineering, you don't have to build up as much knowledge. It's more enhancing your skills, I would say, and being able to adapt. Like, you learn, like I've been doing for Advent of Code. I don't memorize a whole bunch of algorithms. I just learn the core patterns, and when I see something new, I see how I can adapt an old algorithm to that. Whereas I would say medicine, you still do that, but there's probably a lot more book work, a lot of remembering and building on stuff that people have already developed over the centuries. I think here we're going to spore. Wait, no, we're not going to spore yet. We need to fix this bug. I need to find out why. It's the insight. Do you enjoy your work? Yeah, I've done various software engineering jobs, usually related to either websites or desktop software. I've generally enjoyed it, yeah. I think it's like, in my field, in mathematics, normally people either went into finance, and most people went into finance, and relatively few people went into coding or programming or technology stuff. I was one of the minority that went to technology, so I didn't get paid as much as the people who went into finance, but I think the people who went into finance seemed much less happy. They were stressed. They would work like 6 or 7 days a week. They would be so stressed. Like, I think I dodged a bullet there. Screw working in finance. Do your colleagues seem to enjoy their work? Within the tech field? Yeah, I think they did. Alright, here's the bug. Do you think tech is getting oversaturated? No. I mean, in small locations, maybe small cities, maybe it's getting oversaturated, but that's more that's more of a geographical issue, isn't it? I don't think the field as a whole is getting oversaturated. I think there's always more tech people needed. If anything, we don't have enough, and you know, more and more jobs are getting replaced with tech. And many jobs should be replaced by tech. Like, there's many dangerous jobs or jobs that no one really enjoys doing that it's just better to have computers do it. So I think we always need more tech people. Here we go. There's the bug. Let's fix that. So I was avoiding things that I've harvested, but I wasn't avoiding dangerous cells. Now do we win? No. But we did better. That's the important thing. We did better. So at this point, we probably want to just go just grow onto the proteins. Because, I mean, why not? It'll get us more cells. How do I tell them to do that? Just put organ neighbor in that list. Equals. Alright, see you later, Darkslayer. Lambda E to score E1. Danger. What did I call it? Danger spots. Why didn't I call it danger zone? Come on, we're gonna call it danger zone. Danger zone. Okay. So we're basically taking the best candidate here. Return. Let's just say the best cell to grow into is one that's empty. Self.grid.get pause is none. So this will let us grow into our proteins as a last resort. What's wrong here? So now we should see us filling the board. When there's nothing left we can do. There we go. 54 to 64. Not bad, not bad. It's better than what it was before. Try another seed. So then that might fix some issues where we're being blocked by proteins. Interesting, we win that one. Oh boy. We have quite a good aggressive, like, attack strategy here. That's pretty cool. And I think in those situations where we get trapped, this change that we just made now will fix that, because it will let us walk over the proteins and find new ones. So this here is a stalemate. Not much we can do about that. Because he's blocked off every other spot. Alright, I think that was a good change we just made. Maybe we should just submit it and see. That might actually improve. Because I think a lot of games we lost because of that. Getting trapped in tight spaces. So that might actually... Like this, for example. Oh, this is a prime example. So before, I would have harvested these and I wouldn't have left. Like if I harvest the bee, I can't get out. Now, when we get trapped, we'll start growing over the proteins and then get new ones. See? Oh! It was a tie, but they won on proteins, so that was close. Close, but that's pretty cool. All right, let's submit that. I actually think that might improve our rank. should actually probably target tentacles, not harvesters more, because they're the bigger threats. That's quite a close one. In fact, let's submit that as well, because I don't know why we're going for harvesters anymore. No, it's because of an obscure game where taking the harvester one, but I don't see any reason to do that. Just go for the tentacles. Alright, so sporing. What the heck are we gonna do about this? This is a tricky one. So I reckon our first move really should just be to maybe just fire an organ as far as we can somewhere. Just pick a location that's just really far away. Sporing is less important than tentacle. So games like this I'm kind of happy with, even though we're losing, because I mean, we put up a good fight, and it seems like a decent attempt. That one's interesting. Not much I can do about that, but that's what sporing will help with. But here I think we should be using total income, not Okay, just go through all the incomes of each organism, add them all up. That should be fine. And then use this instead of everything. Unsupported operand type int and protein. What? Self.income o.root ID or o in what? Int and protein. What's wrong with this? Let's log self.income. Int and protein. What? Oh, I think some... I think, oh, you need to define a zero vector for sum. So it's got to be start equals... Oh, yeah, it's a reduce. So we need 15.0. That. Generated expression must be parenthesized. Ah, of course, yeah, okay. What happened here? Oh, we run out of A. This is nasty. Not much I can do about that. I mean, we need a good early game to work out how to get to those, but these maps sometimes give you A's which are like you can't reach them using basics. So either we use... No, we can't even use these. We need sporing. Oh, that's horrible though. It's like... So we need to recognize that... Oh, no, you don't need sporing. So he's gone for B, C, and then with that he can actually create tentacles to go get them. It's crazy. Interesting. There is a way we could solve this without sporing. We can say... If... Okay, if we can afford an A, do that. If we can afford a tentacle, do that instead. So it's 1-1. Direction equals next step minus, and then pause. Okay, try that then. So we should be able to grow tentacles to reach A. Let's see if that works. Yes! Oh man, he destroys us. But still, we got out of the lock. Why are we not going for B? Alright, that's weird. So we get A. We need B now. Oh, I see. We're out of C. That's not actually the solution. You actually need to get C. That's a tricky one to solve, but I think that's a good next step. Oh, cool. We win that one. Alright, when do we want to spore? Now, usually, if people are going to spore, they usually do it as the first couple of moves. The thing is, I'm worried that might mean I've run out of resources, and I don't have a smart enough logic to account for that. So maybe I only do it once we've harvested the 3 core ingredients, A, B, and C. So, say after we do harvest, we just want to secure the harvest, and then after we do that, we can maybe spore. I don't know how we want to do this. If we have a spore already, what do we do? Do we want to fire it? If we've already fired it before, do we want to fire it again? Do we actually want to remember if we fired it before? Probably when we want to look at all the cells we can fire on and see which is kind of furthest away from like anything. So to spore, B and D. Let's try this then. Get spore target. So this is Given a spore, we're just going to see what target. We basically want to look at the furthest space and see if it's viable. And we don't want any space that's next to an organ. Oh, our organ. Enemy organ is fine. So... temp equals spora.pause plus spora.direction if Alright, well, okay, so if it's an obstacle or something, if not self.grid dot is growable temp return none. So that means we cannot fire. Otherwise, it is growable. So while it is growable. Hang on. So while this is growable, we want to do temp equals next temp plus Alright, do that. So we just keep looking forward and as far as we can while self.grid.is in bounds. Next temp. So when we do this, temp should be the last viable space, the furthest away. Alright. At that point, we then look at it and say, if there's any of our organs next to this, we don't like it, because we've already got an organism there. Why make another one? So, for neighbor in self.grid.get neighbors of temp if is instance if it's an organ and owner is me, then we don't like this spot, so return none. So if we get this far, we just return temp. That's where we'll just plop the Alright, this is a really confusing Boolean logic. I probably did this in a long-winded way. That's how we get a viable target. So basically spore. For organ in organism organism dot organs dot values if organ dot organ type equals spora, target equals get spore target of organ. So we get the target, and now look at it and say so how far away should it be? We don't want it to be close by. Like, if we were to plop a spore there, there's no point putting it next door, because that's just like pointless. We don't want it to be 2 spaces away either, really. 1, 2, 3. 3 spaces might be alright. If target dot dist organ dot pos is less than or equal to 2, continue. We want at least 3 spaces away. Dot dist. If target is none, continue. Target dot dist is less than or equal to 2, continue. Alright, so we've got a space, it's a few spaces away. And now we want to check that it's not next to any of we already did that. We checked it's not near any of our if target in the void, continue, because that's like dangerous cells. If we get this far, we just want to do it. Oh. We need resources to do this, though. We need that. So we want to say we want to basically do... It's going to be... So it's going to be organ, target, root? How does this even work? Spore. Oh, it's spore. Create a new root. Oh, we need a new method here. We already did it. Spora pause. Okay. Like that. So that's spore. Except we don't have any sporers. So we're not going to do that. Okay. Then we need to create a sporer. So we can say, can we stop logging stuff, please? Take that out. It's going to be like... When... I don't know when we want to do this. When we don't have a sporer, just create a sporer. So we definitely need... So we need that much for the root and that much extra for the sporer. So do it like that. So if we can afford it, if any basically look, if any organ type is, so if not any organ type equals sporer for organ in organs.values. So basically saying if we don't have a sporer, we'll create one and only one. I think that's a good compromise because I don't know, otherwise they'll just keep making sporers and I don't see the point in doing that. So if we don't have any sporer yet, I don't know. Should we just let's try a whole bunch of sporer locations. So candidates equals that. Four. And then we just have to go through For organ in organ, for neighbor in self.grid.get neighbors organ.pos. If self.grid.get neighbor, so self.grid. Is growable neighbor and neighbor not in a void. Target equals okay, we'll say for direction in what directions is like oh, I see. Okay. Do like from direction in map of protein dot from car to maybe northeast southwest. Target equals get spore target. All right. This should be pause and direction, not we're not this, because the spore may not exist. Where it's a hypothetical spore. So from here, with this direction, if target is not none, so we've actually got a valid target, then we're going to put it in the candidates. So we're going to say candidates dot append. It'll just be like the organ we grow from, the neighbor we grow into, the direction, and the target. Okay, and then if candidates so we're here again, we want another scoring function. Score of pause for a given organ and a given target, return, let's say the distance between the two. Organ dot pause dot dist target. Just choose the spot which will actually result in the furthest target. So we say organ neighbor direction target equals max candidates, E equals lambda E to score of E0 and E3. Expected one positional, what? What do you mean one positional? Score, organ, target. That's fine. And we want to grow. So it'll be like this. So it would be organ, neighbor, that's where we're growing the thing, spora, direction, turn. Alright, this is a whole bunch of stuff. Is this actually going to work? Let's try this. So the idea is, if our organism doesn't have a spora yet, we grow one in the position whose target would error n. Oh. Get from compass. Oh my god. What have I been using? I've been using something else. Direction in. Oh god, that should be pause. That should be get from compass. There we go. Not protein. Pauses and proteins. Bloody hell. Okay, what happens? So we spore all the way down there. Well, that's cool. Look, we spore as close as we can. Oh my god. We actually cut off his A. Not that it matters, but that's quite funny. We've now got a little organism there. Oh, that's hilarious. This might work. It's really risky though. Like, well, it's not that risky because we're limited to one spora per organism, so it's not like we're going to go overboard and create lots of sporas, which are just wasting our resources. If we do one per organism, that's probably, and if it screws up, so be it. But it's not that bad, is it? A, B, B, and then we spore down there just for the fun of it. Why not? And now we're growing like 2 tentacles at once. Oh my god, that's so cool. Let's see how this works. Look at that. What? Hello, Kefla. Are you doing CodinGame? This is like, now that we've created a self-replicating organism now. Each organism wants to create a new organism, so That one spawns a new one. That one spawns a new one. Yeah, that's pretty cool. Oh man, this might actually be a really good script now. Cannot grow a tentacle, not enough proteins. What? Why am I trying to grow a tentacle if I don't have enough proteins? I'm still in the newbie league. So the wood leagues. To be fair, the wood leagues are kind of weird because the final wood league, you have to write a sporing routine where you create a sporer to create a new organism. Now, I get that they're trying to teach you to use that mechanic, but at the same time, you can get really far in even the gold league without ever creating a new organism. Like, I literally just introduced this sporing mechanic now. So it's a little, ever so slightly frustrating that in the wood league you need to spore to qualify, because they've written the boss that you literally cannot beat the boss without sporing. Which isn't necessarily representative of the league, because a lot of people don't actually spore and they still do well. I don't know which wood league you're in though. The earlier ones are a bit more reasonable because they teach you to use tentacles and harvesting, which you do need. You do need harvesting and tentacles. You can't succeed without them. Sporing, it helps, but you can get away with not doing it. I'm trying the tentacles now. Yeah, I mean, tentacles is tricky to deal with because you've got to think in terms of targets and like be aware of where your enemy is. Oh, I like this one now. Let's try submitting it then. So this is a whole different script now. So we are only sporing if we Ooh, we're getting lots of wins now. Some wins. Ooh, but that is close. That is a... Oh, no, we're blue. We're blue. Interesting. I reckon we now want to start getting D, because D is needed for more sporing. So let's turn that on. Having a hard time to get the information off the board actualized. What do you mean by that? You're talking about the description or the plan to get the information off the board? Or just handling all the data from your inputs? Oh, you're talking about like how to deal with all the stuff you get from the inputs, right? I mean, yeah, that takes a long time to set up and get sorted and prepare. Like, that's literally a whole day's worth of work there. That's basically what I spent the first day doing. Like, know where the enemies and stuff. Yeah, you have to think carefully about how you store your data. I've created classes for organism, organ, protein. Got a whole bunch of methods here for like adding proteins together, subtracting, comparing, converting from characters, and then we've got like the grid class, and it's got like a built-in BFS method, position vector, so XY coordinates, how to turn that from the compass direction, how to add them together, compare. Yeah, that took me a long time to put together all that stuff, but it makes it so much easier once you've got it all in place. And then my main game class has various dictionaries, storing the proteins, income. Like that's not something they give you, you just have to work out how much income you're getting per turn. Storing the enemy organisms and their locations, my organisms, so on. But yeah, like one of the things you really need to do is just make lots of classes. It helps just making each concept or just like entity in the game. If you can make a class for it, you might as well make a class for it if it stores attributes like an ID, a set of organs which belong to it, so on. Yeah, because one organism here stores a list of all its organs which belong to it. That's pretty important, because then you know which organs belong to which organism. Or if you just want to give a command to one organism, that's only storing his organs and no other organs. And then during my like logic phase, like I often iterate through that list of organs which belong to one organism. Alright, I've just realized there's one very important thing I need to do. When I tell an organism to grow a cell, I need to subtract the protein cost from my stored variable, which is telling me how much protein I have, because the next organism will be using the original protein count from the input, but it'll be wrong because I've just spent some of that. So we need to update. So right now we're probably having situations where one organism creates a cell, but then the next organism tries to create a cell, but it can't because the first one already spent that protein. So what we need to do is subtract the costs. Okay, so if organ type equals basic self.my protein subtract, it's gonna be 1 0 0 0. Also, I've made protein into a vector. That makes it super easy to add and subtract. So now it will just subtract that vector from my protein vector. So basically take 1 from the A and 0 from the others. And once you do it like that, it's much easier to deal with proteins and comparing them. elif organ type is harvester. Basically, this one's going to be 0011. So harvester tentacle 0110. Spora 0101. And then if we do spore, it's gonna be 1111. Okay, that should be better now because we don't waste, and that's a whole turn wasted if you try to build something when you can't. Let's see if that improves. 92 to 87. Can we do better? Oh, we're in the top 300. Wow. To 87. Same. Okay, that's fine. I mean, it takes a few. This is a small thing which may improve some games. Ooh. This is a pure tie, isn't it? No, I think we win. Just. We just win. How is this going? Pretty good rank. Alright, let's just submit whatever changes I've made now. And now let's start thinking about... I'm not sure now. Alright, let's think about if we can see several enemy cells to attack, which one do we attack? Now, this doesn't come up that often. Usually there's only one enemy we can attack, because if there was more than one, like, the enemy would have already kind of attacked back. So, I don't know. It probably won't come up that often. But when we're in a situation where... I don't know. Have a look at these. Ooh, okay. Looks like it's a close one there. See, these... Ah, well, there's a problem. This tree cannot grow a tentacle, not enough proteins. Why are we trying to grow a tentacle if we don't have enough proteins? Alright, what is going on here? Cannot grow a spora, not enough proteins. But we should never be. This should never be happening. Interesting. We should be using total income, not organism income. Hello, Bruce Malt. Yep, using Python. Do love using Python. Okay, I see the problem. Okay, so first of all, total income is what we should be using. Let's take that out. Put that up here. Right, and use that. Alright. Attack enemy. Well, let's try that again, see if we get the same error. Grow. Really? I'm still trying to do it? Not enough proteins. What? Something's wrong here. My protein. I'm always doing protein checks, aren't I? So the key is when we grow, basic harvester and should don't understand. Cannot grow a tentacle, not enough proteins. We've got 1B, 3C. After we grow one tentacle, we should Let's do this. Log before self.my protein and after. Let's check that we're actually getting the protein counts I'm expecting. Huh? Oh my god. Oh my god. Have we defined our subtraction method to add? To be fair, that's probably the only time we've ever done subtraction. So... My subtraction method actually adds. I don't think we ever did any subtraction, though. Yeah, that's not a thing you want to get wrong. Oh, that made it so much better. So much better. Then we don't waste time trying to grow things when we can't grow things. Like, look at that. We should actually submit that. That was a serious, potentially a serious bug. Just remove all this logging. Can we just remove logging statements that we just don't really use anymore? I believe we were adding. Alright, we'll try submitting that then, because that's bug fixed. Alright, what next? Kinda like my program now. I don't even want to fiddle with it anymore. I might just finish the stream early-ish. Like, the things I may like to do would take too long now. One thing I can do, though, is prioritize killing cell enemies with more children. But I just don't know how often that would come up. Is there a situation where it matters? Like, here we're always... Okay, so this actually would come up precisely here. This is a good example. So, oh no, it doesn't. Okay, here. I can attack the enemy from this cell, or I can attack the enemy from this cell. What's the correct answer? The correct answer is to attack from this cell, because that kills him, and that also kills those two. But instead I attack from this cell, so I only kill one. We should have gone for this one. So yeah, we just found a case where we should be for that one, so let's try and fix that. And that will just kill him faster. And then here... Yeah, oof, that's wrong. Look at that. We could kill his root and destroy him altogether. Instead, we went for that one. We should have gone for that one. So you should always go for the enemy organ which has the most children. Okay. But we don't know that yet. We have to compute it. So let's keep this seed up. and try to fix that. So let's say we need to basically we need to build a tree. Either we create like a recursive method and just let it run to compute the Trojan, or we can do the proper way, which is you build a tree. We don't need to use the tree, we're only using it so that we can find the numbers of children, but alright, let's get started on that. So let's say organ. So we're told their parents. We're not told the children, we're told their parents. So once we've gathered all the organs from the input, we have them all in memory. Then we can create a list of organs. Oh, you can't do this. Can't use a class within a... Well, you can't define a type. Well, we can do it without using the type hint. It doesn't like the type hint, but we can still do it. It's just going to be a list of any. Alright. So after we've gathered all the organs together, let's do evaluate income. Okay, so before we do that, let's do game dot organ descendants. Okay. Alright, so what we're basically, we're just going to build up a... just... descendants equals... Why have I done equals? Should be type int. Should descendants would be dict organ to a, or let's just say an organ ID to int count organ descendants. So first we want to just populate all the children. So we want to say for organism in all organisms. So it's going to be self.my organisms plus self dot, so it's my organisms dot values plus self dot enemy organisms dot values. List as a list. Okay. So for one organism, we do for organ in organism dot organs dot values. So we want to look at the parent. So we didn't actually define this. Say parent ID int. So we'll do ID parent ID. Parent ID, and then we need to populate that. So we say this. What's the parent ID of a root? -1? If it's an organ, the organ ID of the organ that this organ grew from, 0 for root organs. Okay, so 0 means nothing. Alright, so, okay, so. Zero means we ignore it, so. Okay, for organ, okay. If organ dot parent ID is 0, we skip it, that's the root. So we have a parent, this organ. What we do is we go to the parent and we give the parent this child in its child list. So we say organism dot organs for this given parent ID, So that is the parent organ. Dot children dot append this organ. So we attach the organ to its parent. Now that we've got all the organs in memory, we can do this without risk of this throwing an error. Okay, so we make one pass to do that. That's a linear pass. And then the second pass, we can now define get num descendants for organ if for an organ ID, let's say, if organ ID in self.num descendants return num descendants organ ID. So if we already know it, return it. Otherwise, result equals 0, or we can say return sum of get num descendants of child ID or child in child ID in or let's say for a given organ if organ.id num then we do that. Otherwise, return get num the sum of the descendants of each child. Are we talking about strict descendants? Because then we have to add the children themselves, don't we? So child ID in organ.children. Wait, do we want to store the children as IDs, or do we want to store them as organs? Probably just store them as organs. How are we putting them in? We'll put the organ in. That way you can actually do more stuff, which we don't really want to do right now, but we'll put the organ in. So here, it's going to be get num descendants child ID or it's going to be child dot ID num or child in organ.children. So you add all the individual descendants, but you add one for the child itself. So down here, we go through all of them and just compute it. For organ, we just say, we just call this once. We don't use the value for anything. We just use the side effect. Actually, no, we don't even do that. We just do it for the root. Where's the root? Organism dot root ID. It's going to be what? Organism dot root ID. That's the root. And to get num descendants of that. Yeah. Okay, so that should populate this with the number of descendants. But let's try test this out. So now we just log. Log this, so it should build up. Count of all descendants. See if it's actually correct. Organ object has no attribute children. Organ object has no attribute children. I think we need to actually add this to the list here. Int has no attribute ID now. What? Given organ. Oh. We're calling this on organs, so we need the child. It's not working. Get num descendants for an organ if organ.adnum in on that and result equals, this is caching, that self dot descendant equals result, return result. That's what it should be. Operator descendants. Oh, that should be fine because we weren't caching it properly. Okay, so it looks like... Alright, so we're saying 12 has no children, correct? 10 has 1 children, correct? 8 has 2, correct? The root, 1, is 5. Looks right. And now... we get to this situation, but we haven't done anything with it yet. But like, for example, here we should go for the okay, so now we want to use that thing. So we say, when we're attacking, return self dot num descendants of enemy organ dot medinum. That's all we do. Descendants, yeah. Try that now. Like that. Okay, now we went for that one. Good. Okay, now the key here. Do we go for... Yes, we do. And then we win. So that was slightly better because we went for the higher profile target. Hello, DAJ. Yeah, the rank is decent. So this time, so last time we went for the harvester. This time, now with this change, we go for the root because he's the higher target. He has more descendants. That should hopefully improve this now because whenever we have multiple enemies to choose from, we always go for the one that has more children. Yeah, so here, we could either attack him here, well, we can't really do that anyway, or we could attack him here. Yeah, well, okay, there's not a choice here. We're sort of blocking off areas, and then we come from this side. Oh, look, and then we come in here. So many orphans. Fortunately, you don't leave orphans in this game because they just die immediately. Yeah, and that was a good target to go for here. Yeah, so we could have chosen between that one or that one. And now we're specifically choosing the one with more children. There we go. Oh man, this is an aggressive one. Look at this. So we get A, we get C, we get B, and then we spore over there. Then we spore down there, spore up there. We're basically overwhelming him. Huh. So let's stop logging this. I don't want to log this. Alright. So if we get A, B, and C early, we still go for D. I wonder if we should still be going for D, to be honest. Like, D is not that important, but then sometimes you only start with... I guess it's nice to have at least one of every protein. But our search for getting protein D could be delaying us, I don't know. Oh, it seems alright. Ooh. What happened here? Oh. Oh, wow. Now that's strange. We killed ourselves. Well, okay. We tried to create an organ from 2 different organisms on the same cell. Oh dear. Okay, so let's try and fix this one. So we don't have memory of where we're putting these organs. So we're saying if we Alright, if we grow, we should actually mark that on the grid as an organ, and that's an organ which doesn't exist. But we should do it anyway, so we should say brute force every possible option and come back in a few billion years and win. If only we could, but we've got a 50 milliseconds time limit, which is more punishing for Python than it is for like C++ and stuff, but I'm not actually using much of that 50 millisecond. We should. Like, there's more, to some extent, brute forcing a bit to use as much time as you can, or allotted, is actually a pretty decent strategy. I'm not really doing that. Especially in the first couple of moves, just like brute forcing all different paths you could take would help you go down a better path. Alright, we need to fix this. So we say, when we create when we grow, Python is 80 times slower than C. Yeah, that's true. And the time frame they give you is equal for all languages. It doesn't matter what language you use, it's always 50 milliseconds, so... I think here we want to just say... we hypothesize that there will be an organ here, so we want to just say group self.grid dot grid it's going to be pos dot y, pos.x. We don't have a method for adding stuff to the grid because normally I don't want to do that. It's like the grid is fixed and we're not controlling the grid. The grid is whatever the game gives us and shows us. In this case, we're doing a hack where we add something temporarily to the grid just to mark that something's there and no one should try to grow there. So we'll do this. Pos.y, pos.x. 10th places using Python. Yeah, I mean, Python users get to the top of the leaderboard because it's not really computation heavy. I mean, C++ and C and stuff have the advantage of being able to do lots of brute force pruning if they want to, but some games are just better for that strategy and some games aren't, and I think this one isn't. You don't really care that much about pruning lots of huge trees. Like, a classic case was the Pac-Man game, which was a couple of years ago, I think. That one really helped by pruning a lot of trees, and Python was at a huge disadvantage there. Here, I don't think it's a lot more heuristic-driven than it is search space. It's not like a chess game where you should be heavy on searching all the trees. Like, there was a tic-tac-toe game, multi-dimensional tic-tac-toe game. That one would also be quite search-heavy. Equals organ. Alright, we'll just create an organ, so it'll be at this pos. Owner is me. ID num. What ID num should I give it? I don't... No, my worry is that at some point I might try to use this ID num for something. We can create a new ID num. But if someone tries to look at what's in this grid and actually call up the ID num, they're gonna create an error. So now we'll just say -1 and hope no one tries. I don't know what my code is doing. Hopefully no code is actually trying to look up that ID num. Organ type will be organ type. Direction will be so if there's no direction supplied, we just go with east, right? Yeah. At this point, it doesn't really matter. We just say direction.campus if direction is not none else. Else. What's this do again? What does it get compass to? Oh, it gets the compass direction from a vector, so we need just, I think we just default to east or something, or north. It's irrelevant if it's a basic, just say north. Let's try that. Okay, there might be an error because I'm just... This is such a hack and it's not... We shouldn't really be doing this. And I'm worried that this is actually going to create errors, but missing 2... Oh, I didn't finish root ID. Well, it'll be the same root ID, so organ dot root ID parent ID. It will be organ.idnum. Okay, so just created a new organ out of thin air, violating the game. Right, as long as we don't see errors, that means our code is probably not trying to use those temporary organs we've created, which I think is fine. I don't see any situations where we're trying to... We now have 74. What did we have before I did that? Let's comment that out again. So we were wasting time before, and we lost before because we actually jammed ourselves in like that. And now that we are doing that, we should never grow over a place where we've already where we're attempting to grow an organ. That's good. I've been using Kreska basically as my test for all of these. Just because I had Kreskas open all this time. So this one is basically a deadlock. A, B, and C. And then we root over there. Do a little bit of capturing. And then this deadlock is kind of unresolvable. The only way you could resolve this deadlock isn't... The thing is, stalemating is good for us if we've got more points. So that's actually good. We don't even want to resolve that deadlock. We want to keep the enemy in deadlock. Because if we keep busy, we keep creating those tentacles, then we win, because we get more points. The only way to resolve it is... So if in the case where we have fewer points than the opponent, and we're in a deadlock, the only way to detect the deadlock would be to notice that the last 5 turns or something have been the same thing has been happening every turn. That means we'd have to store memory, and... can't be bothered to do that. I think a lot of the time it's okay, because if we're in a deadlock, that means our enemy is also in a deadlock. So it's not necessarily bad for us. It's only bad for us if we are lacking in points, but it's not something I really want to deal with. Alright, if I just run through these and see if I can find an obvious flaw, like an error. If we get an error, that's very bad. Oh, that's a nice big map. We lose that one. Okay, so he breaks through here. But we couldn't really have predicted that. Because we wanted to capture D, I suppose. I still don't know whether we should even be capturing D. Like, it's just... maybe it's wasting our time. Let's maybe try turning it off and see if that improves. So we have 84 to 93. Don't worry about harvesting D. Just harvest B and C. That's the most important thing. And then after we've got B and C, just do whatever the heck you want. As long as we've got B and C, we can keep doing tentacles. Let's see. So... so if we just comment that out there, we're not interested in D, and up here we don't store D in our reserve either. We weren't doing that anyway. Okay, let's see if that fixes it. So we don't waste time going for D. Once we've got B and C, we just go on the attack. I think that's better. Now, D is used for sporing, but, I mean, we're not that... we spore if we can, but it's not that important. And now we actually win that one. We've got B and C. And we got D by chance, so we do a little bit of sporing, and we happen to get Ds because we roll over them, but we don't need a supply of D. We just happen to get it. Interesting. So that's... in that particular game, that was an advantage, but I don't know how that'll do overall. Alright, a small one. We need to do better on the small ones, because we kind of suck at small games. Ooh, yeah, nice. Ooh, nice. Keep up the fight. And we've got deadlock here. See, that deadlock would be even harder to detect, because it's not one move that's repeating. It's like 2 moves that are repeating. You do that, and break. So, like, loop detection would be even harder, because you're not looking for one state that's repeating. You're looking... well, yeah, a state would be repeating itself, but it would be repeating itself at period 2. Anyway, are we ahead? Oh, we actually break through. So at some point, he changed his move up. Okay, interesting. And then that led us through, and we win. Okay. Ooh, big bunch of losses there. Big open map, and we win. Are we doing what we want? A, B. Oh, so this is an interesting one. So I used to fail on this because we didn't have enough A. Now I'm using tentacles to bridge the gap. And we get there. That's pretty cool. And see, even if he destroys our spores, so if we make a colony over here and he destroys it, doesn't actually matter, because he's being interrupted, he's spending time and resources fending me off. So that's kind of a plus. And in the meantime, I'm just gaining more territory, so... just throwing spores about is a good thing, mostly. Can I find one where I lose against Kreska? I'm just interested to see what other failings I have right now. It seems it's doing pretty well now. Yeah, we've got a deadlock there, so I think I'll probably lose that. No, it seems equal. Okay, we win, but it was close. Yeah, deadlock resolution is not something I'm interested in doing because that needs a whole bunch of smart logic. So we'll just accept that if we reach a deadlock, our enemy is tied in the same deadlock. Effectively, that's the end of the game, and we'll just hope we have more points. That's crazy. Look at that. But yeah, we interrupt our enemy so much, so it's like overall it's a good thing that we're doing that. Yeah, I think now that we're doing sporing, we have the advantage of, you know, more organisms. I would like to grab some of these Ds though, because it would let us spore more, but I think we're doing good as is. So there's a downside to grabbing Ds. It just costs us more time when we need to attack our enemy as quickly as we can. So I am undecided as to whether we should. I'm leaning towards just ignoring D, which just means we are limited to, like, the number of spores we can make is basically based on our starting D, but we will grab, look, like we grabbed a bunch of D there by chance, so it happens. If you're filling the area, eventually you'll grab whatever D is left, so... Yeah, and I like this because it's sort of just doing lots of tentacles here means that he can't really, even if he destroys my leaves, he can't break into this chain. This is basically securing the chain. Alright, we might submit this and I might actually just end the whole thing there. Like, I don't feel like doing anything more, and anything more would take like a day of planning and stuff, so like I'll submit it and see if we're around 300 or so, and if we're not, then we have to think about what we did wrong and try and reverse it. But sometimes I just I mean, I am trying to get the highest rank, but at the same time, the solution is stable and is doing what I was expecting it to doing. Sometimes it's just nice to just have that, even if it's a lower rank than something I submitted before, because it could be that that was just kind of a fluke and might not hold up over time. Alright, nice bunch of wins there. Let's just... So I'll look at the losses and just make sure they're not errors, because if they're errors... No, that was just a... That was just like... a tie. But he won. It was almost... Okay. Acceptable loss. So we're red. Ooh, okay, he's an aggressive one. We're out of B. So yeah, we cut off our B. Yeah, it's a tricky one because there was a path to the A which didn't involve rolling over the B. If I just tell it to not roll over B, then we get into situations where we get locked in and we can't get to the A at all, and then we just soft lock. So I don't really want to do anything about that, but like shortest path. Well, there is a shortest path to A, which doesn't involve going over B, but I don't know. It means we're no longer using BFS. We'd have to use like smarter pathfinding. Once we're at the B, we can't really do much. So I would say that's an acceptable loss. Okay, he just out-tentacled me. Yeah. Because we don't have any B. It's another weird situation where the only B source was nearby and we kind of can't really get it. Wait, why didn't I get this B? No. Okay, why am I not getting this B here? I'm gonna have to look into this one, I think. Why did we abandon that B? Because we should be getting it. We've got A and C. Now, there's a B right there. Why are we not getting it? What is going on there? Damn it. What's going on? Oh, we don't have any D. You can barely even see the... That's why. That's a bit of an issue. I'm spending D without leaving... enough reserve. Alright. I have an idea. We computed reserve up here. Let's use it when we're sporing. So we don't spore unless we're using our reserve. So harvest. Okay. Get spore target. Okay. If plus reserve and create spore if plus reserve. Right, so don't do sporing or sporers. Don't create sporers, don't create roots if we're digging into our reserves. Reserve is the minimum amount of things we need to create the harvesters. Okay, is that better? There we go. Do we win? No, but it was so close. That's what we should really be doing. Always leave enough reserve to be able to create the remaining harvesters. Alright, let's resubmit that because I think that will really help me. So now we're beating him. We're not sporing unless... we get some D, and then when we do, we throw a little spore here and there. How did we get in there? Oh my god, look at that. We go, like, down there. That's so funny. We just get little organism hiding in there. So I like the fact that my spore is kind of unexpected. Like, sometimes we fling over here, sometimes we fling over here. The unexpected nature of it sometimes leads to unexpected wins. Like, and it doesn't harm me too much to do it because, okay, it costs me a turn, it costs me resources. But it also makes it unpredictable, and sometimes you get wins in ways that the enemy couldn't really predict. Like, I don't really want to fling a spore over there. But I'm not bothered by the fact that he's doing it because, like, this spore over here is good. Like, it helps. So... Alright, let's have a look. Ooh, what is going on here? Oh, yeah. Not much I can do about that. That's just like a really horrible map. Like, what can I do? Like, if I had a better sporing method, I would know to go down there, but he's just outplayed me. Acceptable loss, I would say. Okay, we just lost. We just lost on territory, but I think we put up a good fight there. Why is he creating all those roots there? Interesting. As long as we don't see arrows, I think I'm happy to. Ooh, we migrate over there. Then we have no resources. That's cool. He doesn't finish me off. He has mercy. I become like a vassal state. Like, he lets me live as long as I provide him some resources. Alright, I think we'll just wait and see what what happens here, and I might actually just call it there. I don't feel like adding anything more. There's a risk. Maybe I like some of these wins, as long as I don't see any weird correctable errors. Like that one, okay, that's nasty because there's only one way out, and if the enemy blocks me in, then that's it. Like, what can we do? Yeah, these situations where there's only like one or two exits, that's not, yeah, not easy, and my algorithm's not good enough to handle those, I guess. Yeah, those are the ones we lose on. I can accept that. What happens here? So neither of us actually get to the A. Neither of us know how to get to the A. Well, that's yeah, well, that's a very hard one to do, but I mean, he gets more points. Ooh. Yeah, no, yeah, that's fine. All right. I'm just waiting now. I don't really want to do anything. It's only 60%. I don't know. I might just end it there and say, that's my bot. Like, I don't see anything that needs immediate attention. Like, I don't really want to be rolling over this C. Why are we doing that? I thought I wasn't doing that. Let me have a look at this again. P for P in self.proteins. If self.grid.get P so avoiding all the positions which have protein that's in this priority list. We shouldn't be going over the C then. What? Wait, no. What was the one I was looking at? This one? Oh, I don't have it open now. What was it? Yeah, he's aggressive there. I can't really defend against that. Well, that seems to be correct behavior for my bot. So why don't we spore here? Okay, so now we've harvested. We should be able to spore because we just don't have enough D. And we can't even get D because he's blocked us off. So yeah, that's just really smart bots. We're up against a lot of smart bots. It's difficult to do anything. Oh, we're ranked 256. So I think for the most part, I'm just hoping I collect D on the way because it's... I don't really want to collect D. I don't really want to spend the resources to get it. I don't know. Alright, we'll just wait until this stabilizes and then we'll see. 238. How long have we got to go? 86%. It looks like we'll end up around there. Yeah, that's pretty good. Well, it's the highest amongst the people I follow right now. Okay, I'm hungry, and this is almost done. We'll wait until it stabilizes for the sake of the video, so it actually appears on the video. We can see where I end up. So we fling over there. That's quite fun. Oh, but then he flings. Oh, he's just replicating like crazy. He left one guy alive. Ooh. I mean, once he's got in there, nothing I can do, really. So basically, we killed our source of B. Yeah, well. If I didn't, then we'd be trapped in this, so it's had to break out, but then we need another source of B. It's kind of what you use sporers for, to like bunny hop over the bees. That's leapfrog over the bees. I don't want to do that, that's too complicated. But you kind of need to leapfrog over them if you want to. Well, no, I mean, there is. It would put, if I went for that bee instead, we would be able to get out. Yeah, well. Question of choosing the right. Those sources. Like, if you can pick 3. Yeah, that's the point. Like, it wouldn't be too hard to write a simulation in the very first turn. Write a simulation which just tries all combinations of 1A, 1B, and 1C, let's say, near to us, so in our half of the board. So that would be not that many. And then see if we can draw a nice chain that links up the 3. I don't know. Tomorrow, I might, if I'm doing another stream tomorrow. I mean, there's 1 day and 19 hours, so actually I could do another stream tomorrow. I did say this was going to be the last one, but I still have a really weak early game. I've mainly focused on the late game stuff, like attacking, but if I can improve my early game, that might actually be better. Like in this situation, we need to grab the C. I don't even know what you do. I suppose you can. Grab that C there. stabilized anyway. 232. That's a pretty good rank. I mean, we'll hold on to that, and maybe tomorrow I'll try a new thing with the early game. Try and map out the best 3 to go for. Maybe even include D. Like, the problem with ignoring D now is that I just don't have enough D to create lots of spores. So maybe I should really go for D. I don't know. Okay. That's enough for today then. So... yeah, we made good progress today. We pushed up a couple of 100 spots. Tomorrow, I guess we can experiment with that. And if it doesn't work, whatever, we'll just stick to the code I have now. That's good enough. Alright then. Thanks for watching. See you next time.